Welcome back, everyone. I hope you had a refreshing lunch break. We now begin our afternoon session with Lecture 11 to be delivered by Professor Gautam Makwana. In this lecture, he will speak on research paradigm and frameworks in AI, ML, data analytics, and allied technologies. We are delighted to invite Professor Makwana to take us forward with this important session.
Okay. Yes. Uh, Good afternoon to everyone. This is the third day and the lecture number 11 regarding the topic is the research paradigm and the framework in the AI, ML, data analytics and allied technologies. So up to now we talk about the many things about the AI and ML. Okay. Now to deploy the AI system, we require the other technologies. Okay, so we will discuss the other technology, how we can use to deploy or make the some kind of the framework to make the complete system, which is the AI based system. So in this my agenda, I will talk the as a case study for the digital health scale systems, how it can be used the different technologies in the making the all digital healthcare system to deploy in the big cities or across the state or across the countries. Okay, for this case, we are having the different technologies. We require the IoT, cyber security, ML and AI, virus technologies, fog and edge cloud computing, big data and the data analytics, wearable medical devices, and the smart sensors. So there are the different kind of the issues to deploy this technology into the one digital healthcare system. So also, we will discuss some of the issues regarding the this technologies and some kind of the mitigation technology using the AI. Okay, so before starting my content, I acknowledge this three people that is having the based on this contribution. I'm making this topic is suitable for you. Now the first is the IoT. What is the IoT? Okay, the IoT is the one kind of the you can connect the different kind of the object or things from the any locations, from the any kind of the devices, or anybody can connect with the internet or any kind of the infrastructure, any networks or any business, and anytime, anywhere. So this is one kind of the taking the data from the at different locations. It may be near, it may be the medium range, or it may be the long distance. At any time, anywhere, and any device can be connected into the on the internet to collect the data. So there are some kind of the technologies, some kind of the sensors are required to collect your data from the different locations. So there are a concept about the smart devices, or I can say it is a smart sensor. And using this one, we can make the correction of the data from the various point in the various volume and various categories. Now, this is one of the applications. So there are the many applications you can make the uh, IoT application in the smart cities, transportations, smart home, smart retail, smart agriculture, industry, manufacturing, robot, environmental purpose, and the health purpose. So for this case, for the different application, we require the different kind of the sensors and different kind of the connectivity between the internet and the object. So we can, if you connect all the devices, so we may connect all the applications from the small region to the larger regions in the geographical point of views. So this is with the help of this IoT, we can correct the data in the different way for the different applications. Now, what is your digital healthcare system? So for this case, we consider the only within the one room, within the one room. I may be in the ICU or maybe in the any room in the hospitals. So for this case, the patient and there are the different kind of the sensor are surrounded. It may be the temperature sensor, brain wave, blood pressure sensor, wearable devices, and all this data are connected into the this device that monitor the condition of the patients. And then after it may be connected to the doctors, and all the data are connected with the some kind of the server, or it may be some kind of the edge kind of the devices. And then it is a all these devices are all the this data are distributed among the edge computing server, or it may, and it is also connected to the cloud computing. So here it is a combination of this. All this is a known as your IoT kind of the structures. And then after we have the edge computing and the cloud computings. Okay, the then and then only we have to make the this is a known as a one kind of the health-scale IoT, or I can say it is a digital health-scale architecture. So with this help, we can provide the affordable health-scale system, remote health monitoring, wellness management, virtual rehabilitation, faster disease diagnosis, drug discovery, remote surgery, early disease detection, and mechanism for the error prevention. So this is for the betterment of the serve the patients in the different aspect, and we are using the AI here. Once you correct your data efficiently, so this is the one way we can integrate the IoT, edge computing, and the cloud computing with your AI. Now, so if you just see, so there are everything is this structure is divided into the four layers. The one is the perception layer, that is your physical layer, and then it is the network layers. So network layer will contain the how the your IoT are connected with the edge, how the sensor are connected with the doctors, and that is a contain the your network layer. Then it is the cloud layer and the application layers. Okay, so here the perception layer is the sensor, patient monitoring, blood pressure, ECG, EMD, or whatever kind of the your biomedical sensor are connected. So this will come in the perception layer, network layer, cloud layer, and the application layer. Now, what are the issues in the this kind of the IoT solution for the digital healthcare system? The one of the issue is the cyber threat, cyber securities. The first I will discuss about the what kind of the cyber threat or cyber attack in the each layer of the structures. Okay, so in this case, the perception layer, the type of the cyber security attack in the perception layers. The perception layer are having the physical mediums. So there are the seven type of the attack are on the perception layer, or it may be the physical layer. So and this perception layer are referred to the physical layer that serve the purpose of the sensing and collecting the essential information about the patient through the biosensor, unable to interconnect the stakeholders such as the doctors, nurses, pharmacists, and the medical instrument, and communication with the RFID, BLE, Bluetooth Low Energy, wireless sensor networks, Zigbee, IP version 6 over the low power wireless area network, that is the 6 low WAN, and the LoRa, LTE, and 5G wireless technology. So these are the wireless technology used in the IoT's point of views. Okay. Now we will see the what is the meaning of the each and every attack in the physical layer. The first one is the jamming. So that is a malicious actor may interrupt and block the communication between the sensor and the receiver, leading to the absolute downtime, lack of the availability, disrupt ongoing surgeries, and the medical diagnosis access the online system. So this is the one of the attack. Jamming will create the disruption between the sensor and your receiving bodies. Physical attack is the unauthorized access, tampering, and the malfunctioning of the hardware devices. It is come under the hardware cyber security attack. And then it is the eavesdropping, which is the malicious exchange of the critical and the confidential information between the device, or it may be the RFID tag and readers. And number 4 is the injection attack, injecting the malicious code, injecting the malicious code and modify the firmware of the IoT devices, causing the complete operational disruptions if the single inject node disturb the entire network. So these are the consequences of the injection attack. And the fifth one is the tampering. That what do you mean by the tampering? It is the manipulate the node memory. Okay, force on and off of the devices, force restarting of the devices, and the stealing the key code and the manipulating the data. Another attack is the cloning. That is your RFID cloning involve the replicating and the receiving the reader with the duplicate the tag that read to the unauthorized access of the information. And then it is the interference attack number 7, the interrupting the network traffic and the broadcasting the radio wave for spreading the false information. So this kind of the attack are in the your physical layer of the your IoT system. Now in the network layer, the main purpose of the network is to deal with the data packet transmission to edge and the cloud layer, routing of the packet and the multi-hoppings. Enable enable the different wireless communication technology, that is the Wi-Fi, 5G, 6G, NB-IoT, LoRa, WiMAX for the data transmission over the different frequency band and different coverage through the OFDM, multi-unit MIMO, and the energy efficient routing protocol, very high throughput protocol. So these are the main function of the network layer, and these are the 7 attack in the your cyber 7 attack in the network layers. The first is your DOS and the distributed denial of the service. So what do you mean by the DOS and the DDoS? A hacker attempt to consume the legitimate network resources or bandwidth during the denial of the service. Attack and the distributed denial of service when it's originated from the multiple node and fall into the traffic fragmentation attack. This attack are flooding the internet protocol, internet control message protocol (UDP), leading to the delay, resource consumption, potential system crashes, and the disrupting the services. So this is the between the network to network. If this attack will occur, then the whole system will be affected because of the flooding of the wrong message or wrong control message. And then it is the main in the middle attack involve the intercepting the communication between the two devices to capture the sensitive information. So it is one kind of the hacking the data during the communications. Generally, in the any system, there are the data are the two kind. Whether the data is sensing, data in use, and data is communications. During the data in the communication and data during the storage. So at the time, the hacker will try to take this data during the different kind of the cyber attacks. Sinkhole attack. So this this attack will do the redirect or discard the traffic, preventing from the receiving the full data transmission that spread the misleading the routing details, increase the energy consumption, and reducing the network durability. Now IoT are the energy constant devices. In the IoT, most of the devices are the energy constraint. If the something is a hacker will try to consume the more energy, then that device will be the that device will consume the more energy, and the battery will battery is over. Then that device will not be the come in the not in the capture the data from the particular sensors. Okay, cyber attack that is a registered node are impersonated by the malware to redirect the traffic toward the malicious nodes, toward the malicious node which are having the multiple identities. This attack a wrong flow of the information within the network that affect the data integrity and the resource allocation. So instead of the source to destination, if the cyber attack will occur, at the time your data will be routed into the different direction and the different destinations. So this is the effect of your cyber attacks. Now, what is the spoofing attack? The spoofing attack occur when the malicious entity intimate the registered users resources like the MAC address, IP address, and URL or email. So here, what happened? Whatever the devices in the IoTs, or if you know, hacker will get the physical address of the devices in during the your network layers. So at the time, if someone will get this address, then the having the control to others, hacker will get the control to divert the traffic in the any fashion. So that is to gain the network access illegal that breach the data confidentiality and the integrity of the environment. Traffic analysis. So generally, most of the protocol are the controlling the traffic. Okay. Now a hacker will try to attempt to increase the traffic, even though there is no traffic actual in the network layers. So this will become the creation of the false traffic to guess the transmission of the critical information such as a key password. So suppose any computer data is sending the only actually it is sending the one time, but with the help of this attack, it will send the multiple time, and the hacker will get the idea about the what kind of the what kind of the password into your data transmission. So it is possible to access the password of your authorizations. Now, in the same way, there are the two other attack is the routing attack. This will give your selective forwarding the attack in which control packets are deliberately forwarded within the routing protocol for the raw power and lossy networks (RPL), which is one of the protocol in the use in the IoT in the constraint node by dropping the data packet. So here the attack is the reply attack, capturing and retransmitting the packet capture from the nearby node by an unauthorized node to obstruct the transmission of the data packet in the network. So this kind of the attack is it will not fulfill the need of the RPL. Okay, so it is give the some kind of the unauthorized node to obstruct the transmission of the data packet in the networks. Now, third layer is the cloud layers. Okay, so what is the main function of the cloud layer in the digital health scale system? Deal with the storing of the information, processing of the information, and sharing the information between the authorized stakeholder. Here, it is involved the AI, ML, DL algorithm, data analytics, and TCP, UDP protocol. So here mainly it is a 5 attack. That is the flooding the attack in the cloud malware injection, signature wrapping attack, web browser attack, and the SQL injection attack. So this is your type of the attack in the your cloud layer. Flooding attack is what? Overloading the servers with the enormous traffic generation through the excessive messages transmission, which cause the denial of the service for the registered users. Malware injection is inserting the malicious code or service in the cloud. This is the malware injection in the cloud layer, inserting the malicious code services into the network, appearing as a registered component already present that cause the downloading of the harmful or malware software and opening the malicious email that lead the attacker are able to execute the malicious activity and gain the unauthorized control of the cloud server. So we are getting the many link on the WhatsApp and the email. Okay, if you click, then the some data are accessed by our confidential data will be accessed by the hackers. So this is a known as your malware injections. Okay. signature wrapping attack. This is malicious access of the resource of the clouds, such as the virtual machine, computing facility, memory by signature wrapping of the password. So suppose I want, if someone is want to use the resource of the cloud, so we need some authentication of the your to use the particular resource of the cloud. So by using this attack, and we have to pay the money to the service provider of the clouds. So without paying, if you do this attack, then we can access the all the resources of the cloud. So this is the one of the attack that will access the various resources of the cloud servers or cloud computing. Web browser attack. Attacker can gain the access to the victim computer, corrupt the file, or use to the hack machine to attack other. SQL, this is a known, okay? So it is the access the web browser. Sometimes the hacker will access the important content of the website, okay? The SQL injection attack is the inject the malicious SQL query to achieve the malicious objective such as a modify sensitive data and confidential data crashing of the server. So these are the type of the attack in the at the your cloud server. Now in the application is the main concern is to provide the user interface which include the service to the stakeholder of the healthcare, smart home, and the connected car. So these are the seven attack in the application layer of the Edge IoT. That is the DOS, WS, code injection, malware, phishing, MITM, buffer overflow, and the XSS attack. So we know what is what do you mean by this attack in the application layers? Okay, so this distributed denial of the service attack are carried out by the group of the compromised computer operating from the multiple locations that flood a particular target with the traffic to make the server or website or online service unavailable. So it is at the application layer. Code injection attack will inject the malicious SQL code into input field for the data and code isolation to target the user's browser running of unauthorized script application from anywhere for the data breaches and the system malfunctioning. Malware attack use the malicious program such as the rootkit, spyware, adware to commit an offense on IoT applications that affect the national security, social impact, and the economical domain. And the phishing attack are the attacker impersonate a trusted device such as a sensor, a smartphone, smartphone appliance, and send the message that appear to be authenticated to obtain the credential to authenticate or identify the use for the criminal purpose. For example, click on the malicious email message disrupting the healthcare facility. So this kind of the thing are the this attack will be the to access the some important information about the healthcare systems. MITN man in middle when unwanted or malicious scripts are executed without the user's consent, then that lead the data breaches, system malfunctioning, or other vulnerabilities. Buffer overflow attack. If the buffer is overflow unnecessary, even it is empty, that result the application may crash, memory access error, memory override, or leak confidential information and corrupt the file. And the XSS is the cross-site stripping attack. So in this case, harmful code is embedded into the authenticated and trusted website to alter the content of the applications. This attack can control the device directly, sending the users to malicious website or coding the direct domain to the devices. So this attack can access the cookies, session identifier, and other confidential information. So these are the almost 22 type of the attack in the IoT healthcare system at the different layer, physical layer, cloud layer, network layer, and the application layer. Now, how to mitigate this layer using the AI and machine learnings? Okay, so here it is a come is a so this is a your uh, different kind of the use cases for the cyber security point of view. Okay, so here it is the 0-day attack detections. No attack in the one day. Okay, this will give the my reliability of the systems. Okay, then it is a predictive analytics for the threat anticipation. Now, if any threat will come, so what is here in the AI and ML? It is suppose in the DL, it is take as the input. Whatever the thread, it is take either your data set, and based on that data set, it will predict the whether it is an attack or not. Okay, so this is the kind of the predictive analytics for the threat anticipation, identify and access the management. So here, mainly it is what you call to access the any information. We need the some kind of the authorization of the your users. So here to identify the double securities. Okay, generally what happen, we are having the key, credentials. Okay, so this will provide the 2-level or 3-level security to access the data. That is known as your identify and access management. HIoT device behavioral analysis. So this is the one of the use cases where to get the idea how the devices are behave during the normal operation, and to whether your device is attacked by the hacker or not. That kind of the behavior will be studied in the this kind of the IoT device behavior analysis. Now this is your intrusion detection and prevention system. So how to prevent the attacker to enter into our healthcare system. So that kind of the prevention and to detect the intrusions, this system will work. And then it is a edge IoT device communication. So during the most of the your data transfer are the wireless. Okay, so during the wireless transmission, how we have to secure the your secure the data transmissions. Or that is a concern about the here. It is what happened. The frequency of the communication is the important. Okay, so if you someone will transmit the some same frequency, and this connect the data is transmitted from the sender, then it may possible to detect what you call change the your data during the transmissions. So that kind of the thing can be the prevented here by using the proper proper security in the communication during the data communication during the in the between the your edge IoT devices. Then it is your anomaly detection and the prevention. So there are the many anomaly detection in the healthcare system. So that you have to reduce. Then it is a attack. We want to classify the attack also at the different layers. How we can classify the attack, and then it is a data prediction to how to protect the stored data at the different layer, physical, network, and the cloud and application level. That will come into the this kind of the use cases. So there are the many attack. There are the 22. This is the just number about the 22 attack, and it is happen at the different locations. Okay, it is not like the only one attack is happen in the only one point. It is happening in the different level of the different level. It may be either in the physical, either in the cloud, or either in the network, or either in the application layer. So we have to consider the and the type of when you same attack will come in the different layer, then the damage will be the different levels. Okay, so this kind of the study is required to reduce the your attack in the digital healthcare system. So now These are how AI techniques used to mitigate the cyber attack in the edge IoT. So all algorithm. So this is your dynamic fuzzy C-mean clustering, customized by RSTM. So this is used for the mitigate the botnet based DDoS, zero-day network attack, and the benefit is to separate the attack from the regular data. Separate the attack from the regular data, security handle medical data, and analysis attack pattern in the IOMET. Uh, 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 Industry, Internet of the medical things. This kind of the techniques in the AI, multi-step, CNN, stack RSTM, which is non-aerial, MSCSL, light spectrum optimizers, LSO for the optimizing the MSCSL hyperparameter. So this is for the this kind of the attack, port scan, brute force, and DOS attack. And the benefit is that data adaptability improved, reduce computational complexity, high precision and accuracy. And another technique for the to mitigate the cyber security attack are the pre-classifier based network inclusion detection model. That is for the man in the middle attack. Reduce the input data dimension effectively, accelerate anomaly detection. This is another technique used in the for the cyber security point of view, hybrid intelligent intrusion detection system. KNN decision tree hybrid approach for the feature selection and classification. So this technique is used for the cyber attacks such as the IP sweep, port sweep, Smurf, Blood force target cloud server containing the electronics health record. The benefits are malicious traffic detection and the prevention in the edge IoT application, made heuristic algorithm for the feature selection, reduce the computation cost, hybrid approaches improve intrusion detection accuracies. There are many others. It is a novel DDoS detection algorithm and DDoS preventive algorithms. This is for the DDoS attack, a distributed denial of the service. Effectively detect the DDoS attack and system that restrict the access to the attacker. Another technique for the cybersecurity attack are the fuzzy minimum min max neural networks based on the fuzzy set SVM for the classification. So these are the along the this for this under this technology techniques under this AI algorithm this attack are covered. There is the DOS, remote to local, user to root, and there is a benefit is the non-linear class boundary can be learned in the one pass, detect the inclusions more effectively, reduce the error rate. ML algorithm and the deep neural networks that will mitigate the this kind of the this attack. That is the replay, MITM, impersonate the privileged insider, remote hijacking, password guessing, and the DOS attack and the malware attack. So this is the benefit is we can classify and detect the different kind of the attack at the different level, network and the host, detect the anomaly reliability. So these are the use of the AI in the digital healthcare system at the different layer on the your to mitigate the various kind of the cyber security attack. Now, as a to complete the edge IoT, so there are a different kind of the category. This is the one kind of the category is the cyber security attack. Okay, so there are another kind of the this category in the digital healthcare system. So one is the then after that we can get the complete enable end-to-end data privacy. That is by the scripting anonymizing and the pseudo diamonding to mitigate the this of the data bit. So these are this method we can get the uh, uh, we can make our data secured. Device vulnerability risks are the devices are the what is here a device manufacturing risk is the all the devices along this HIoT device are the manufactured by the different manufacturer and having the different concern by the design and the privacy by design metrics leading to the unscripted network services inadequate authenticate and inadequate security concern. Okay, so this is the one of the risks that all the devices of your digital healthcare system are manufactured by the different vendors, and they have the different concern about their design criteria. So there is some are the some devices are the not good in the cyber security point, and some devices are the good in the cyber security point of view. So this is the difference between the there are the vulnerability there are the what you call uh, in this case, device to device, manufacturer to manufacturing are different concept about the your to integrate all the concern into the your one systems. The third risk is a service reliability risk. A service interruption or failure of the connection that affect the emergency response and the real-time monitoring. So we require the 5G and the 5G beyond with the IoT provide the seamless communication between the multiple devices. So during the emergency or during the surgery, okay, remote surgery, if the connection will fail, then it is the lack of the connection will be the loss between the doctor and the who are doing the surgeries. Okay, so we need the uh, uh, reliable communications between the two devices to make the remote surgery without any disturbance or seamless connectivities. And this can be done by the advanced wireless technology. So during the Wi-Fi or during the WiMAX or maybe the Zigbee, there is a possibility that the reliability is less in the some critical regions due to the some reason the connection may be lost. So for this case, we require the 5G and the 5G beyond wireless technology with the IoT provide the seamless communication between the multiple devices. Then it is a ethical risk. So already many things discussed. What is the ethical risk? Harm to privacy, harm to property, and misuse of the technical resources. So these are the other kind of the risks in the digital healthcare system. So uh, how we can integrate the how we can solve this category the risk into your digital healthcare systems. Now there are the to mitigate this risk. There are the many mitigation techniques. One is the of course AIML, inscription, access control, authenticate, blockchain, and firewall and the antivirus and the digital signature. So this technology is used to make the with the minimum risk analysis of your digital healthcare system. Now, in the same way, as a patient, we need the different service from the digital. We need the different services for your digital healthcare system. The one is the payment management, lab analytics. When you go to your lab, at the time we have to wait for some time. So, this service requires the immediate analysis of the your report. Then it is the medical evidence, information technology, online appointment, communication, and e-prescribing, and medical history and the reminder. So this is the what it is a big data and the data analytics. So there are many data is generated for the many patients, and the requirement of the service are the different, very person to person. Okay, so in this case, for the e-health system, we have to concern about the data, uh, big data. It is how to solve, how to use the big data and the data analytics into the to provide the your e-health system. The patient can access their medical record online, receive the remote consultation to manage the health and other e-services increase day by day. Other are the consistency, security, and the interoperability in the IoT integration, privacy concern, and the regulation complicate the adoption of the large-scale technology. And these are your reliable communication, low latency, high data rate, and through the 5G technology. So to provide this service, we require the multiple cutting-edge technologies. Okay, so this is your not only the AI and ML will provide all the solutions, but we have to integrate the other technologies into the making the digital healthcare systems. So earlier I just discussed the uh, earlier I discussed that this simple IoT in the single room, and even though there are the many type of the technology are required. Now suppose if you want to deploy this same technology all over the city or all over the state or district, how to how to deploy this AI based digital healthcare systems. Okay, so for this case, we want to make the framework. We want to make the uh, a framework for the deployment of the a framework for the deployment of the this edge IoT. So here in this case, what happened? This is the one a simple building, one hospital maybe. This is the your simple one hospital, and this is the second hospital, or maybe the there are the in this is the one kind of the one city or one region of the local region of the your cities. So in this case, we want to connect, and this is the one. This will indicate the your body area networks. This is known as your body area network, where all the sensors are connected with the patients. Okay, depending upon the type of the disease or type of the disease having the in the persons. So, this is your body area network, where the number of the sensors are connected with the patient, either in the wireless or maybe the wired sensors. And this network is connected with the one kind of the SPS, the base station, which is a non-area base station at in the your hospitals. Okay, so it may be here it is showing the only one person, but actually there are the many patients in the one hospital. So all are connected with the this SPS server or base stations. Okay, now here this will indicate the your small base station transmissions, small base station transmission. Uh, Now, depending upon the now what kind of the virus technology is used. Okay, suppose the your hospital area is the within the 100 meters, or it may be around the 500 meters. So how we connect the this body area networks? How we connect the body area networks? That will decide the your virus technologies. Okay, so for this case, there are the different kind of the virus technologies: short range, long range, and the coverage area. So from the 0 to 50 kilometer. Okay, so we need that based on the coverage area and based on the data rate. Okay, we have to select the particular virus technologies to connect the this body area network with your small base station transmissions. Okay, so if the data is we require the large data rate and the small coverage range, we have to find out the particular selection of the wireless technology, either maybe Zigbee, Bluetooth, Wi-Fi, optical wireless communications. So this is for the short range. Now, in the same way, here all the hospitals are connected with the this MBS. What is the MBS? MBS is your macro base station, uh, transmissions. So all the hospitals are connected with the uh, MBS. That is the milliwave backhaul, wave backhaul. Now, in the same way, what happened? Uh, some patients are at the home. Some patients are the home. It is not inside the hospital. Okay. So here this is your case where your body area networks. It may be either in the surrounding the hospital, or it may be the inside your home, or it may be the outside the room. So how they are connected, okay, to monitor the health care system. So this is your case when this will connect it through the direct to the MBS. Okay, MBS is your macro base station, and here the connectivity will be your macro base station transmissions. Okay, now in the same way, all this data are connected with the core network and the data centers. So here what happened, the scenario is a multiple hospital and the multiple patients are connected across the cities, and how we connect how we make the use of the technologies in your AI based healthcare systems. Okay, so here we have to use the different technologies, different framework, and depending upon this virus technologies. Okay, so in this case, whatever happen up to the 50 kilometers, up to the 50 kilometers. Okay, so we want to deploy the AI based system into the larger geographical areas. Okay, so here it is a different kind of the virus technologies. It is not necessary only one virus technology are enough to make to deploy your AI based healthcare system. We need the multiple virus technologies starting from the Zigbee. Okay, suppose we need the uh, high data rate, huh? High data rate and the medium or up to the kilometer range of the coverage. Okay, suppose in the case of the emergency treatment occur at the time the doctor are at the hospital, but the paramedical professional are at the location where the emergency treatment are required. So for this case, we need the uh, seamless and the reliable communications between the doctor and the paramedical persons. Okay, for this case, it is coming the 5G and the 6D. And at the same way, we have to transfer the data. It may be the images or it may be the videos. Okay, so at the time we want to send your data from the remote location to your doctors. So for this case, we want to use the 5G technologies between the doctors and where we want to emergency is required, to where we want to make the emergency surgeries on the patients. So these are the case of the 5G technologies. Now, in the same way, other than the data rate and the coverage range, there is also the need of the latencies. What is the latency? It is a time will take to send the data from the one end to another end, and then it is reverse back to the senders. So it is a round trip journey of the data from the sender to the sender to destination and destination to sender again. So this is known as your latency of the your communication. Because if you just feel when it is an emergency requirement, at the time that this delay will be the more, then the purpose will not be solved. Okay, so depending upon the maximum uh, the latency will be the required in the within the milliseconds. Okay, so this can be possible with the 5G technologies. Okay, and the order of the minute the latency will having the in the Zigbee or unlicensed LP WAN or licensed PAN are having the latency in the minute. Okay, so this technology are this emerging technology are very useful when you deploy your AI based systems. Okay, and there are the many kind of the research area where how to integrate or how to deploy the any AI based system into the larger areas. So this is a framework. Okay, it is showing the different locations, one building, multiple building communication, and a person are moving other than the inside the building. It may be in the home or it may be in the car. At the time to monitor the condition of the patient, we require the seamless and high speed communication network, and this can be integrated uh, to the your AI enabled technologies. So earlier, now this is a framework is for the not only the medical point of view. It may be used for the smart cities. Okay, where the AI solution for the one area, it can be deployed into the multiple area of the your cities. Okay, so this is a simple framework to deploy the AI based solution into the larger area with the connectivity. And connectivity is depending upon the emergency, medium emergency, and the high emergency. So depending upon the requirement, we have to make the communication between the different devices and the server. Okay, so this is your this uh, here it is all other communication will be the wireless communication, but in the core networks, it may be having the wire backhaul. It may be the optical communications, or maybe the depending upon the uh, datas. Okay, and with this core network, another city will connected. So suppose, for example, if I take this is the Ahmedabad city. Okay, and if you want to connect this with the same system into the another city like the Surat. Okay, so at the time again it is this same will connected with the core network. At the time everything will be the connected. If the patient will go to the Surat, then also come in the integrated with the this system. Okay, if the doctor will go to the some another place, then because of the not availability of the doctors, sometimes we suffer. The patient will suffer a lot. So at the time, what happen if you connect the everything at the different locations, then after the many problem will be just solved into the medical point of views. So these are the just idea about the how to deploy and how to deploy the AI based system into at the large scale by using the different technologies. So only AI based solution will not work. We want to deploy into the real practice. Then and then only the purpose will be solved. So this is the case about the 5G healthcare for the remote medical assistant in the emergency situations. So this is the case that when some accident will occur. Okay, at the time the doctor will not reach at the patients. Okay, at the time the ambulance will come in the picture, and the whatever the person uh, in the ambulance, it will give the first treatment. Okay, And this is not a doctor. Doctor is sitting at the his office, his or her office, and this is your case. Now, based on the data, now how to collect the data at the remote area, at the where the accident is occurred. So at the time that we want some device that capture the images or videos of the patients. Okay, and depending upon that, depending upon the injuries, the doctor has to give the some kind of the instructions with the minimum retencies. Retency will be the minimum because the accident is placed 10 kilometers away, and the doctor hospital so it will take the time to reach the patient at the hospital, and it is maybe possible to more damage to the patient. To avoid these things, we require the 5G health skill for remote medical assistance in the emergency situation based on the AI. Based on the AI. So whatever the data captured at this site, it will send to the doctor, and doctor will get the idea about the what kind of the treatment is required. Okay, so this is the just, idea about the use of the AI and the various technologies. Okay, it is not only AI and ML will work, but we require the technology in the cyber security point of view. Okay, we want to now because of the cyber security attack, more than 30 to 40%, more than 30 to 40% patients are suffering because of the cyber attacks. Okay, and so this is the idea about the how to deploy AI-based system on in the digital healthcare system. So this can be replicated into the others domain also. Okay, so this is the suppose the in the smart cities. So this kind of the deployment can be possible into the same way with the different technologies, or maybe the some same technologies. So there are the IoT, then the cyber security, edge computing, fog computing, and cloud computing, and then it is now is coming the quantum computing. Okay, and then it is a wireless communication, wireless technologies, and blockchain also is coming. So all the technology are integrated, and then only you can provide the good solutions to the as per your domain. If it is medical, then this is one example here. The same example can be used in the different domain, like this way. So these are the this is just one domain. Else we can go for the same kind of the deployment research framework for the smart cities, transportations, smart home. Okay, now for this case, transportations, it is from the road, railway, by sea, and by air. Okay, so there are the different domain of the transportations. So how to integrate this domain into the single framework to make the maximum optimized use of the transportation service to minimize the cost of the transportations. So these are the one of the example: a smart home, a smart retail, a smart agriculture, industry, manufacturing. Now smart agriculture. So we are talking about only one farms, but to integrate this AI-based solution into the all the farm in the Gujarat, then we require the this kind of the framework. Okay, so generally people are talking about the all the smart agriculture into the one farm only, but there are the research into the integrate the same solution to the multiple farm in the one state. Okay, so this is a case about the this ones. Okay. So in the same way, it is the environmental, and this is a So this is a future research framework for the all these domains. Okay, and not only the AI ML, but it is require the integration of the others technologies, and there is a your uh, uh, there is a need of the this lecture actually. This is a yeah. Any question?
Sir, can we apply some
प्रतीक्षा बेन आवे प्रतीक्षा बेन. Okay. Okay. Yes, madam.
AI or ML based technique to design core security algorithms?
Core security.
Algorithms.
Yeah, there are many use cases. Okay. Core security in for networking or
Basically, suppose let's say for example, integrity based new solution. Many solutions are available. Many available rather for achieving, but they are time consuming. But can we apply some AI or ML approach to integrity achieving algorithm?
core integrity in which sense? You framework. This framework. Yeah, everywhere we can use the mainly. Yeah, this is the one of the actually generally people are talking about the suppose the AI is using in the this domain only. AI is used between the this to this only, but the overall I never seen the up to now. In ML because it is a case to case study here.
Yes, yes.
Okay, and this is why I put the this future. I have never seen. I have look at the latest papers 25, but I never seen this kind of the solution by using the AI single algorithms. Okay, but this can be possible only when you combine the many algorithms.
Yes.
So here we want to integrate the multiple algorithm at the different levels.
Yeah. Thank you, sir.
Yeah. Okay. So we will take the 5 minutes. Yeah, yeah. You announce the group name. Okay. For yeah, yeah, she is announcing. Group.
Folks, please pay attention. She is going to call out the partaker, the name.
So here's the case study paper group list. Group 1 has Professor Kumar Shah, Professor Peenal J. Harit. Is that all?
Can you raise your hand when you are in group and so others can see who their partners are? Only one present.
You huh?
Okay.
Okay. In the signing said they have let them announce.
Okay. So for group 2, we have Nikunj, Prajapati Kumundrini Baldev Bhai, Shailesh Bhai. Okay.
We are here. Perfect.
For group 3, Rijwani, Nishant Sharma and Bhumika Patel.
At least two are here.
Okay. 4, we have Janak Suthar, Sameer Singh Ashok, Shri Praveen Kumar Shah. Group number Darshit Doshi, Zalak Bijal, Rahul P. Joshi. Group 6, we have Chahan Rashik, Girdhar Ajuria, Nikhil Kumar Singh. Okay.
You identify your.
For the next group, we have Adhyay, Khata Vijay Panjab Varade. The next group, we have Dinesh Kumar Salitra, Pankaj Modi. None of them are here.
I'm concerned for that.
The next group, we have Dr. Jeet Choudhury, Dr. Vishal Rathod. All right. For the next group, we have Dr. Mittal Anamika Khushalbhai and Dhwani Modi. For the next group, we have Makwana, Joshi Deepyaman Rakesh, Prashal Kumar Manubhai. Okay. For the next group, we have Sushil Kumar, Nidhi Jha and Selson Kapap. Okay. The next group we have Davesh Shail Amit, Sheikh Mohammad Faiz and Gohel Dhruv Kalpesh Bhai. For the next group we have Purva Waghela, Gangani Ankur Nitin Bhai and Prajapati Meet Babu Bhai. For the next group we have Anuj Dhameja, Lajja Brijesh Gajjar and Harsh Parekh. For the next group, we have Maria Tahir Faki, Rishika Raval, and Thanki Bhavisha Jitendra Bhai. For the
Third one is here.
yes. For the next group, we have Surbhi Prajapati, Prajapati Prakash Kumar Natwarlal, and Archie Luvaria. All right. Next, we have Hanan Abdullah Muhammad Utifa, Ayushi Mehta, and Jyoti Kumari Nayak. The next group, we have Professor Hiren Joshi, Professor Vaishnavi Solanki, and Dev Delvadia. For the next group, we have Professor Sarman Hadia, Fapale Ishwari, and Tanya Majithia. None of them are here. Okay, so that concludes. Yes, ma'am. The first group has Professor Pratima Krunal Kumar Shah, Professor Peenal Patel, and Vishal Harit. Okay, so is everyone clear with their group members?
હા પેલો કાગળ બની ગયો.
So how many total groups?
There's no group number
એ
mentioned.
કાગળ છે ને ઓરિજિનલ કોપી જે છે ને
Just a
પેલા
second,
સંદીપભાઈને
ma'am.
આપવાની છે અને સ્કેન કોપી કરીને મને મોકલી આપજો મારા મોબાઈલમાં અને વોટ્સઅપમાં.
There's 20
Email ઉપર
groups
અને
in
WhatsApp
total.
ઓછી તમારી પાસે બધી કોપી તમે તમારી પાસે રાખો પછી હું કરેક્ટ કરી દઈશ.
So does anyone have any questions about their groups? That's great. So, so, so great. Okay, so with that, we move on to the last lecture of day 3, which is Generative AI and Quantum Computing, delivered by